Hello everyone, this is Blender Guppy. Welcome to the Creative Flow version 1.65 and Random Flow 2.85 changelog video. Okay, so let's start with Creative Flow first. And first off, we have the fast mirror or auto mirror, I mean. So auto mirror for Creative Flow and also in Random Flow and also for the standalone fast mirror add-on. They will now work in edit mode. So if you're in edit mode and then you use the operator and then click on the axis, you want to mirror the geometry. There you go. So the process will still take you in object mode inside the model operation in order to properly initialize the script or work the script and add the mirror modifier. But after you've set the axis and then press space or enter to confirm, you will be brought back to the uh, past mode of the object, which is the edit mode. So we start in edit mode, auto mirror, confirm, then we're back in edit mode. So that now works in edit mode. And we have changes in the draw cuts. So I'm using polygonal. So if you press control near a vert or a middle of an edge or middle of a face, it will snap on that point. There you go. So middle of an edge, middle of the face, or a vert. Okay, and then draw cuts. And also in the draw mode, both in edit mode and object mode. So in object mode, it creates drawing an object mode creates an object, of course, to be used for Boolean or just a base mesh. So in polygonal, we now have, you can now set the last segment, and the last segment will be the striped line right here. So for example, if I do this, so the last segment will be that one here. So from before, the last point is the last segment, the one that's moving. So you kind of like, in order to do a shape like this, which is snapped to the first point and also snapped to the last point to create an aligned edge like that, you have to basically shift alt and then let go of the shift alt and then not moving the mouse cursor, press space or enter to confirm, and that can be really awkward. So right now you can just set the final segment by clicking, and the final point, which is the moving one, the moving edges, will no longer be um, considered for the shape. So the last point will be this one, okay, like that. So it's much easier now. So if you're using the old version and you get this update, it can be a bit confusing at first because, of course, from the last version, uh, the moving uh, the moving point or the last point is included. So right now, the last point, you have to click the last point, and the last point or the last segment will be represented by this striped edge here. Then click, and you have your shape. Okay, so that is the changes for the draw faces or draw cuts in edit mode. So the snapping needs to be near a vert like that. You can also do it using the other shapes. Also encircle. And using strips, so just press Control. You can combine Control Shift for the alignments. So like that. Okay. So those are the changes for the Creative Flow add-on. We have the auto mirror, which can now work in edit mode, and the draw faces, the snapping, and the changes in the polygonal drawing. Okay, so now let's move on to random flow. So random flow, we have a new operator, which is the random slice, and basically what it does is create this random squares. So you can choose to have it drawn like that, which is just cutting the mesh. And we have the solver random. This is random, and the shortest. Okay, so you can see that this is mostly rectangular and squares, but they're not too close to each other. The edges are not too close to each other. And using the solver random, you can see this really thin faces. So with tangent, tangent means the longest edge in the face. It will follow that direction. So for example, and also, yeah, and also some a shape like this, it will follow that. Okay. Slice. Okay, there you go. And we have the view, which of course follows the view of the viewport. I mean the axis of the x y axis of the viewport as you're looking at the faces that you've selected. So if you bring up F9 again in a different angle and click on view, F9, click on view. Okay. So tangent, we have origin. So view doesn't have the origin. So view is the uh, x, and it's just x and y, and depends on the angle of the viewport relative to the object and to you. Okay, so Final Cut, no, not Final Cut, random slice, and go to tangent. We have the edge. Using the edge, it will follow the shape of the edge around it, around the face. And using XYZ, it will just literally draw the lines in straight X, Y, and Z. So if if an edge is slanting or like that, the drawn line will no longer follow that shape. So it will just be straight on the X, Y, and Z axis. Okay, so like this, for example, like this. Okay, and edge. Okay, cut amount, the amount of cuts that you can do, the amount of cut lines on the selected faces. And we have the seed value, which of course randomizes the pattern. So be careful with the cut amount because as you increase the number, of course, the operation will slow down. So let's go somewhere like 300 and minimum length. So 400, and okay, minimum length means the shortest, the shortest length of an edge in order for it to be considered as a cut line, or yeah, in order for it to actually be cut in the faces that you've selected. So if I increase the minimum length, it will get rid of this really thin faces. And you can see, if I increase this, you can see those really thin slices of faces. just disappear. And as I increase it some more, of course, the margins or the size of the face becomes less constricted or thin. So basically, shortest is like a shortcut to this kind of configuration of pattern. So for example, if you're using 0.005 or 0.01, 0.05, there we go, or 0.025. So you don't have those really thin slices of faces. But if you want to quickly just have this kind of pattern, you can just use shortest. Random means that you have the minimum length property. Okay, and you can have those really thin slices of faces. So slide means basically just these faces as they are cut. So kind of like this. Okay, as they are cut, you can control where they are on the edge of the face. They are being cut. So basically just a randomization property. So you can play around with this. So something like 0.1 for the minimum and 0.9 for the maximum. And this just changes the look of the pattern of the cut faces. Okay, 1.9, you have really thin slices of faces, and then you can control it with minimum length. So we have the thickness. The thickness is reserved for the separate mode. With separate mode, it doesn't cut the mesh. Okay, it creates another object, cube r slice, another object, and this is a non-destructive method. This is a destructive method. Using the separate object, it will create the effects as a separate object, which is a non-destructive method. Then you can play around with this thickness value, and we have so this is the thickness value, and the depth, which is of course the height of the insetted faces or extruded faces, and you can play around with the depth seed, and we have the scale. So thickness is kind of like scale, but if you increase this and the faces on top becomes too thin, this can create geometric distortions, kind of like that. So just something like 0.001 can do, but sometimes 0.001, depending on the size of the faces, can also cause geometric distortion. So in order to basically open this up, if I take away the cavity and just the cavity, you can see that from this view it's not really, the detail is not discernible unless we increase the thickness, and then the detail becomes apparent. You can also do that. Oops. R slice separate. You can also do this using the scale. So bringing it down. So I'm going to get the cavity back. Okay. So scaling, bringing the property value down, scales it down. And you can see that it's causing less of a geometric distortion even with the small faces, because it is using the scaling method. Basically scales the top faces. Okay. So something like 0.936, just to open up the faces. And you can also randomize this because we have the min max value. It will randomize between the value. Right now, it will randomize between 9.936 up to the one value in max. So like that. Just creates really good variation, especially when creating buildings. You're not just stuck with really squares like that. You can have objects or inserted faces that, of course, scale down. Okay, and you also have the proc, which of course determines if that face will be inserted or extruded. So with the separate mode, since this is a separate object and not attached to the source mesh, the faces that are not inserted are deleted. So you get this kind of effect. Okay. So separate with the proc value. You can of course randomize it. And the material index of course works like any other random operators. If the source object has any material, -1 will of course take out the active material in the source object, and 0 is the first material in the list. If you want this first material on the list, you can select 0. Second material is 1, and so on. So we have the wireframe here. If this is separate and not merged, you can have the option of wireframe. This will result in the cut lines being like the wireframe effect. This is not using the modifier. Instead, this is real geometry. Okay. Just so you have the effect as a cut line for your models. If you want the effects to be discernible in renders, but not use it as just a drawn line. So you have wireframe. Floater means that it will not cast shadows or be reactive to the diffuse and glossy shaders around it. So this will look like it's part of the mesh underneath as long as they share the same material. Okay, that's the purpose of the floater toggle. So set cycles render visibility to make it look like resulting mesh is part of source mesh. Okay. So wireframe, again, don't use any boundaries. So that means that the boundary edges, it refers to the boundary edges here in the selection. So use boundary, it's solid, don't use boundary. Excuse me. Don't use it's not solid, but it's created an additional face to actually uh create a more solid border, but not actually really solid because at the back, oh, it is solid. Okay. So yeah, a solid border using the use boundary. So limited dissolve, if the limited dissolve works on the source mesh. So for example, this is this topology. This region of the mesh has this topology, and we use random slice. Random slice works on every independent set of independent faces or individual faces. So you can see here, we disable the wireframe and disable and use merge. You can see that it works and cuts on every individual face in the selection. But if you want this planar region just to be a single face, you can use limited dissolve. There you go, just a single face. So the merge one is destructive. Let's try it with the separate and use limited dissolve. So yeah. So it's using all the selected faces. Let's use proc to 1% and use limited dissolve. Right now, those faces are a single face. So what's happened? what happens is kind of like this. Limited dissolve. So it now works on this region of the mesh as a single phase. Okay. So in object mode, random slice will work as a separate object. The result will always be a separate object. Okay. In edit mode, you have the option to make the drawing, of course, wait, limited dissolve. Make the drawn cuts be destructive or merge to the object. But in object mode, the result will always be a separate object or a non-destructive process. And then you can choose warframe also here. Floater, use boundary, all that options. Use mirror. Use mirror is go to mirror X. Use mirror. We have the clip center. If you have mirror, same as any other operator, it will basically clip the center line based on the distance threshold. So using this use mirror, toggling it off, it will of course get rid of the effect of the mirror modifier and basically random slice the entire mesh as an applied mesh. Just the applied version using the mirror modifier, it will disregard any other modifier like the bevel or subdivision. It will just get rid of apply the mirror modifier and then use random slice on the applied object. But your source object is of course still intact. It's using the virtual duplicate of this object with the mirror modifier applied and using this operating on the applied mesh of the source mesh with the mirror modifier applied. Okay, so in edit mode again, let's apply the mesh. In edit mode, using merge, you have the option to be destructive. You can have it as just a drawn line like that. Then you can select faces. If you want to, of course, do this manually, you can of course do it like that with the drawn lines as your guide, or we can also have the inset effect in edit mode without having it as a separate object. So for example, like that. So in order to have the inset effect, you need to toggle on inset. Okay? But this process is, remember that this process is destructive. We also have the proc. And all the other options that you have using the separate, which is the thickness. We have the random depth. We have the random scale. And you can, of course, play around with the scale seed and also the proc seed. That play around the proc seed. Okay. So a bunch of options here. You can do it destructively or non-destructively. Okay. So that is our random slice. And it will work optimally on angular models, which is basically just the angles are pretty straight. You have slanted stuff like that. What it will not work on too good is for curved surfaces, organic forms. And it also, unlike the other script, which needs the faces to be quads or tris in order for the subdivision to work, this doesn't require subdivision because it will basically just draw on the faces to create the effect. But the resolution, in order for it to be, it works optimally on resolutions that is lower than you use random panels for. Random panels you can use for something like this. Oops. Random panels. So it will still work fine. But as the resolution increases, the base resolution increases of the source mesh, random slice speed will of course already be. So right now we're using limited dissolve, but if we're not using limited dissolve, increase the cut amount, its speed will be affected by the resolution of the faces that you're using. And you can see that if we inset this, the effect is really not that great because the cut details are working on the individual faces. And if we limit dissolve this, the result is much better. Okay. So it works on low poly and mostly angular objects. So if we use it on a sphere, for example, the result wouldn't be pretty because of the amount of faces involved to create the shape of the sphere. Okay. We cannot, of course, limit dissolve this without affecting the shape of the and the topology of the sphere. If we use random slice on this, let's just auto smooth this first. Random slice, and then use random slice, and you can see that the process is already slow. If we increase this, it might crash Blender, so yeah, it won't work on that. But for probably for some other surface like that, it can work. Okay. Here's the resolution. And you can see that most of the details are already bunching up at here, so it's not really that optimal. You can still make it work for something as simple as this, but as you can see, the XYZ, this is mostly for low to mid angular objects. So that's random slice. So for the buildings that you saw me create using random slice. So for example, like this, random slice, increase the, let's go to edit mode, create the effect here. So good thing about this is, and also the cut amount reverts back to 100 every time the operator, every time you use the operator to avoid crashes on your future selections. So we use 300 on the last operation. If I select this face and use, so it will revert back to 100. So for example, 50, if we use 100 on this face, on that size of the face, and use the same value on this smaller face, you can see that the details are smaller because of the size of the face. Okay, so what we need to do is decrease this in order for this to be more in line with the detail of the overall object. For example, here, you don't do this because now it looks too detailed, like versus the rest of the model. So something like this. Okay, and you can of course use Shift R. So for example, if you have a setting like that, select the face, Shift R, Shift R. We are in edit mode. This is destructive. Just select a face, Shift R. If you haven't lose the connection on the Shift R repeat command, it's meaning that it was interrupted. So just use the operator again. And then you can use Shift R again. Select the faces. Okay. Shift R, Shift R, Shift R. In edit mode, the more faces that you will have, the more faces the source mesh will have will have a detrimental effect on the overall speed of this operator. If you continue, if the resolution becomes too high, this becomes lower as you increase the cut amount. Because the way it works is that once it in order for the faces, in order for this faces to be inserted, it needs to find these faces amongst all the other faces in the mesh. So the script cycles through all the faces just to find these faces. So meaning that when looping through all these faces, the amount of faces that you have in the source mesh, of course, affects the looping or the uh, cycling script. You probably can have a base, you can have a base, then the rest of the detail you can just create as a separate object in edit mode, just to make the base model lighter. Okay, just switch, or you can just use this, use it in edit mode and just use this separate mode. These objects will be created as a separate object. And when you're finished, just select everything connected to this model and press Ctrl J. You don't need to boolean this. Just press Ctrl J, or you can use random flows, join objects, and then auto smooth. There you go. That is our random slice. And I also created in edit mode the face select. Okay, the face select is, you can use it for, you can even use it for random starship. You can use it for random slice or many other operators here. So if example, for example, we raise this up like that randomly, like that, or maybe not, just like that. So use vertex groups. Select a vert on the top faces, then Shift G, vertex group. It selects the top faces but doesn't selects the side faces. But if you happen to forget setting this, you can just use the face select operator. Select all the faces. You need to have you need to select the faces in that which the operator face select will work on. Okay, this needs a selection in order to filter this selection. In order to filter the selection, of course, face select, and we have linked flat faces. I mean length. So this is works like the minimum length. There you go. So this the faces that have this short edge has been deselected. Only non-manifold, non-manifold. Or you can use the limit mode without using the length. Non-manifold, this selects all the faces that are that have edges that are non-manifold. And only non-manifold, non-manifold. Okay. If you use none, you can use the length. And if you have something like that, you select. Okay, this has been deselected, but it's still part of this face, so we can use link flat faces, and there's a sharpness here. So it selected this part here because it's connected to this face here. And so that's the it kind of works like the link flat faces command. And when you increase the sharpness, it basically just selects all the faces on top connected to this active face here or selected face. Okay, face select invert, which is of course just inverts the selection. Face select and select invert. Okay, and this also works great on random starship. Just a random starship here and increase the subdivision. Select everything and filter the selection using face select. Deselect invert and toggle on link lock faces. So faces that are deselected, which is still in the planar regions of the selected faces, it will select those based on the threshold, of course. So you have that, you have those thin faces deselected and those big faces in the top area selected. So you can just go ahead and go in object mode, use random panels. Oops. Okay. Radio. And create a detail like that. Okay, so the spikes here, we have the non-even inset mode. And this is also a new feature. So, so like that, you can select those faces, those stop faces using the face select. Okay, so that we have random slice, and then in the mesh in edit mode, we have the face select. Okay, extras, cleanup, utility. Okay, so we have the you saw the you saw the distortion there, depth, and then this is the inset. Let's try 2 or 0.5 and play around with the panel size. I want to recreate the distortion. I can't seem to recreate it now. Just kind of okay. Increase the there we go. Increase the subdivision. So this is a result of the inset process. If we even if we set the thickness to 0, it doesn't disappear, or the depth doesn't also disappear. So I exposed the property which allows you to select between the even and the non-even mode or method of the inset process. So using non-even, we'll get rid of the spikes when using random panels. It is also in random loop extrude, inset mode, even, and non-even. So from before, I was using these two in random axis extrude, and it will create a bunch of spikes like this, which sometimes can go on towards infinity. So right now, we can avoid that using the non-even mode, inset mode. And so for example, if I use the same uh, mode on just this plain cube here. Random panels, even. Okay, increase the subdivision. And I'm going to show you how the difference between the two. Okay, depth. Okay, let's use random height. Okay, so when you increase the value of either the depth or the random height, it goes on like that. So the offset is even. The offset of the faces is even. If you use non-even, this is the result. You get this result, but for certain topologies, you get rid of the spikes caused by using the even method. Okay, so let's use random access extrude here and increase the duration to something like 10, something that can still work without crashing. Okay, using the panels here and no subdivision and even, okay, and decrease the, okay, even with just the small amount of, use this small amount of depth, and even with zero random height, we are seeing this spikes. So in order to get rid of that, you can either play around with the panel seed from before or mark sharp those areas that creates those um, spikes, but sometimes they can be too many. So you can just use non-even in this case, and it gets rid of most of the only caveat is that the offset of the faces are not even, but you get rid of those spikes, even and non-even. And you can just of course play around with auto smooth to get rid of the flat shaded faces, and they still, in some distance, they still look like even offset. Okay, even if the default value of shade smooth angle 30 degrees will not work, just play around, like increase it to 45 or 90 until you see the mesh smooth it out. Okay, so that is our new property for random panels and also for random loop extrude. You get rid of the spikes. And then we have random loop extrude, random cells, random scatter, tubes. So with random tubes, I have fixed the distribution of the tubes. They will no longer be, for example, in this one, let's reduce the curve and the depth of the curve, or the width or the radius. Increase the resolution to have more faces and more pipes. Okay, so right now, when you play around with the seed value, the pipes or tubes are now distributed evenly and randomly. So from before, they kind of bunch out in this part, or this part, and this part. They're not really distributed along along the selection. So right now, I have fixed that, and also there's an added toggle here which is the use fallback. Because say for example, if we're using 20, so looking at this, everything is kind of noodly because in the script, if the pipe has nowhere to go, it will result if all the edges tested negative on the uh, first condition to create a segment, it will instead fall back on an available edge even if it does not meet those conditions. So that is the default. By toggling this off, when all of the edge does not meet the condition to create a segment, it stops there. So it doesn't use any fallback edges, and the segment creation stops there. So clicking this, the the resulting pattern is that the tubes looks less noodly. Okay, so use fallback and with it on and with it off. And then we have the bevel offset. So the bevel offset, you can randomize this, of course, with the min and max having a different value. You can randomize this. But I've introduced a new toggle here, which is the chain looking icon. Uniform bevel, use single property value for bevel offset. If you use this, if you click on this, then you can no longer randomize the bevel for each corner vert. They will just use the uh, single a single value. There's no more randomization. The property being used for the unified strength or factor is the maximum. So for example, if I change this to 0.01, and this is our minimum, if I use the unifying value or the uniform bevel toggle, it will use the maximum property here as the single property value to control the bevel offset. Okay, so that is for the pipes, and that is also true for random panels, which you see here in the bevel. You need to increase the offset. Okay, you can randomize the bevel, and then you can also use uniform bevel like that. Okay, set this to 0 and set this to 0. Okay, so we have we have the inset mode and also the uniform bevel toggle. Okay, so and another one, random panels, is the bevel type. The bevel type um, the panel pattern. The bevel we have a new property, which is the type. We have the inset, which is the old one. Creates a raised geometry to create those panel cut effects. And then we have the bevel. The bevel type, which of course is destructive. As you can see here, this is our source mesh. We created subdivision and it's also subdivided the selected faces. This is a destructive process. Okay. It doesn't create a raised geometry, but it will destroy the source mesh to create those effects. Okay. Not Final Cut. Increase subdivision, and we have the width here, and we have the offset. Okay, so this is our bevel type. It will always create a cut on the border edges. This will probably change in the next few updates, but for now, it will also create a surrounding cut on these selected faces like that. So if you have something like this, it will create those cuts on these faces, on the border edges. Okay. So that is our bevel, bevel type, and this is a direct uh, um, direct copy of the algorithm used in Final Cut. So in Final Cut, this process is you can just use it on the selected edges, but with random panels, you can of course this is of course used for randomization. The radio increase the maximum amount of faces. So in order to avoid this, you can just insert the selection. I think we have, do I have margin? No, I don't have margin. I'll probably introduce margin. I'll introduce margin to create the uh, inset effect before using it. So to avoid creating cuts on these edges here, so we can insert the selection and then use the operator, and you have this. Okay. So I'll introduce it before I pass the update. Introduce the property here. So just so you know, that will be the margin property, and its effect will be basically creating a margin on the selection, then using the script to avoid having the cut on this sharp angle edge here. Okay, so that is our bevel type. So in Final Cut, you can just use it on the selected face. There's a bunch of other effects too. That so just select the face and then Final Cut. So this is for manual panel cutting, not randomized. Okay, so random panels, we have the new bevel type, and then random slice and tubes. Random color. I think I've already explained that. Or have I not? So random vertex color, just in case I haven't passed this yet, we have a new limit sharp. It's basically so object colors are different per object. Select the colors are different per selected face islands, and island colors are different between each separate face islands, and sharp is different. And sharp color is different between the sharpness of the faces or the edges, surrounding edges. So if we set this to black, this is to white, So and we match up the ship. Okay. So just like that. You can also use dirty vertex color and all the other and all its additional options here. Okay, so what else? Cables, no change here yet. So probably in the future updates, I'll focus more on tubes or cables to see what other stuff I can add to it or make it better. And yeah, I think that's it for the random flow version 2.85. We have the random slice, which is really good for um, low poly objects. So this is the one. And you see me use this on creating buildings and all other stuff. Buildings and city blocks and vehicles. Okay. So from before, I'm only using plate and set for vehicles. So right now you can use this. You can also use this on spaceships. As long as you follow the advice I've told you about the resolution. So keep it low. Okay. And keep the mesh angular. Okay. So that's it for the changes for the ice flow and random flow add-ons. So I will pass this I will also attach this video on the email saying that the store is updated. If you happen to see this video without seeing the email, that means that the store has already been updated too. So the product will not be attached in the email. When you receive the email or see this video about the update, log into the store you bought the add-ons from and then get the free updates from there. The emails are just to um, basically tell you that the update is live. Okay? To remind you that the update is already happened or live and that the files are in the store. Then after seeing that, go to the store, log in, and then get your free files or updates there. That's it. And if you have any questions, use the comment section or the description in the this of the video. Thank you for watching and have a nice day.